In Python, when are two objects the same? It seems that 2 is 2, and 3 is 3, will always be true in Python, and in general, any reference to an integer is the same as any other reference to the same integer. The same happens to none, i.e., none is none. I know that this does not happen to user-defined types, or mutable types. But it sometimes fails on immutable types too. That is, two independent constructions of the empty tuple yield references to the same object in memory, but two independent constructions of identical one immutable element tuples end up creating two identical objects. I tested, and frozen sets work in a manner similar to tuples. What determines if an object will be duplicated in memory or will have a single instance with lots of references? Does it depend on whether the object is atomic in some sense? Does it vary according to implementation?
Python has some types that it guarantees will only have one instance. Examples of these instances are none, not implemented, and ellipsis. These are, by definition, singletons, and so things like none is none are guaranteed to return true because there is no way to create a new instance of none type. It also supplies a few doubletons, one true, false 2, all references to true point to the same object. Again, this is because there is no way to create a new instance of bool. The above things are all guaranteed by the Python language. However, as you have noticed, there are some types, all immutable, that store some instances for reuse. This is allowed by the language, but different implementations may choose to use this allowance or not, depending on their optimization strategies. Some examples that fall into this category are small integers, -5, 255, the empty tuple and empty frozen set. Finally, Python returns certain immutable objects during parsing. For example, if you run the following script with Python, you'll see that it returns true. This seems really odd. The trick that Python is playing is that whenever it constructs a function foo, it sees a tuple literal that contains other simple, immutable, literals. Rather than create this tuple, or its equivalents, over and over, Python just creates it once. There's no danger of that object being changed since the whole deal is immutable. This can be a big win for performance where the same tight loop is called over and over. Small strings are entered as well. The real one here is in dictionary lookups. Python can do a blazingly fast pointer compare and then fall back on slower string comparisons when checking hash collisions. Since so much of Python is built on dictionary lookups, this can be a big optimization for the language as a whole. One, I might have just made up that word, but hopefully you get the idea. 2, under normal circumstances, you don't need to check if the object is a reference to true. Usually you just care if the object is truthy. For example, if some underscore instance column ... will execute the branch. But, I put that in here just for completeness. Note that this can be used to compare things that aren't singletons. One common use is to create a sentinel value. Or the moral of the story is to always say what you mean. If you want to check if a value is another value, then use the as operator. If you want to check if a value is equal to another value, but possibly distinct, then use equals. For more details on the difference between is and equals, and when to use which, consult one of the following posts. Is there a difference between equals and is in Python? Python none comparison. Should I use is or equals? Addendum. We talked about these Python implementation details and we've claimed that they're optimizations. It'd be nice to try to measure just what we get from all this optimizing, other than a little added confusion when working with the as operator. String interning and dictionary lookups. Here's a small script that you can run to see how much faster dictionary lookups are if you use the same string to look up the value instead of a different string. Note, I use the term interned in the variable names. These values aren't necessarily interned, though they could be. I'm just using that to indicate that the interned string is the string in the dictionary. The exact values here shouldn't matter too much, but on my computer, the short strings show about 1 part in 7 faster. The long strings are almost 2x faster, because the string comparison takes longer if the string has more characters to compare. The differences aren't quite as striking on Python 3.x, but they're still definitely there. Tuple interning. Here's a small script you can play around with. This one is a bit trickier to time, and I'm happy to take any better ideas how to time it in comments. The gist of this is that on average, and on my computer, a tuple takes about 60% as long to create as a list does. However, foo_tuple takes on average about 40% the time that foo_list takes. That shows that we really do gain a little bit of a speed up from these interns. The time savings seem to increase as the tuple gets larger. Creating a longer list takes longer, the tuple creation takes constant time since it was already created. Also note that I've called this interning. It actually isn't, at least not in the same sense the strings are interned. We can see the difference in this simple script. We see that the strings are really interned. Different invocations using the same literal notation return the same object. The tuple interning seems to be specific to a single line.
It varies according to implementation. Python caches some immutable objects in memory. This is true of small integers like 1 and 2, -5 to 255, as noted in the comments below. Python does this for performance reasons. Small integers are commonly used in most programs, so it saves memory to only have one copy created, and is safe because integers are immutable. This is also true of singleton objects like none. There is only ever one none in existence at any given time. Other objects, such as the empty tuple, may be implemented as singletons, or they may not be. In general, you shouldn't necessarily assume that immutable objects will be implemented this way. Python does so for performance reasons, but other implementations may not, and Python may even stop doing it at some point in the future. The only exception might be none, as X is none, is a common Python idiom, and is likely to be implemented across different interpreters and versions. Usually you want to use equals instead of is. Python's is operator isn't used often, except when checking to see if a variable is none.
If you want to see more, please subscribe.